So here's some class notes if you are absent. This will be brief, hopefully. What we did today is we learned about a very special form in the world of exponential functions. So I'm going to start here. This is, again, the class notes page, so page 3 of your homework packet. Exponential functions. The form, kind of like the slope-intercept form that you guys have learned in the past, which was a very important and handy form. Exponential functions has its own handy-dandy form, and it is yabba-dabba-doo. It's y equals a times b to the x. That is an exponent. So what we are going to learn, or what we did talk about today, is that we know that a function is exponential if you have a variable as the exponent, okay? So that might be a good thing to write. If there is a variable as an exponent, okay? Then it's an exponential function, okay? And this is going to be, you can do some fun stuff with this, actually. So if we look over here to some notes here, exponential functions are defined by an equation of the form, so we can just write the same thing. It's good to keep writing it because this is definitely one to remember, okay? I think that I always learn this as yabba-dabba-doo, and we're just like exponentially going up. I don't know. If that works for you, great. If not, sorry about that. So the B, if I look at B, this is going to tell me a lot about what type of exponential function is. If this number is greater than 1, then we call that an exponential growth, okay, function, because it's growing, and I'm going to model some of that in just a minute, and it is, if you think about it, increasing. So we have something that's kind of growing or getting bigger and kind of drastically. It starts off kind of small and then it goes boom. And it just keeps going up. Now, if a is greater than 1 and less than 0, the function, we actually call that a very special and kind of macabre term, which is decay. Okay, but decay is, it is dying. It is getting smaller. And it is decreasing or getting smaller, okay? So again, I can say if the B here, right, is kind of like it's smaller, right, than 1, but greater than 0. Remember, it is going down. B greater than than 1, then it's growing, okay? The asymptote is a very fancy word for a line. So it'll be clear when I model it, but it's simply a line. So when you start graphing these great things, which the graph gets close to, it doesn't touch, but never touches or crosses, okay? So I will, that'll make sense. So when I'm wearing my Snoopy pajamas tonight. Nice. So we're classifying this, first of all, and we are going to start with number 1. So again, this is the class notes, by creating a function table, which you should have done a lot of in the past. I like to have a third column here to show my work, and I'm going to have my X and Y. I like to do this neatly so I can keep track of my numbers, my data, and my coordinate pairs, which we're actually going to end up creating right now. So let's start with the golden 5, I like to call them. So You probably have chosen these before when you've done other types of functions and graphing, is that you choose some numbers that are negative, some that are positive. You like to choose 0 to see what happens, and that will get you a y-intercept. And then what we're going to do is we're going to take these values for x, because x is the exponent, okay? And we're going to work it out, and we're going to put it through our machine, and we're going to get our y value, because we've been talking a lot about functions. So I always like to start with 0, because it's just such a great number. So if I think about my work, what I am going to show you is that this means 2 to the 0 power, right? Because I'm just using 0 as my exponent. So anything to the 0 power is what? 1. It's 1. Now I'm going to take 2 to the first power, because this whole column are my exponents. Anything to the first power is the number itself. Now I have 2 to the second power, which is 4, okay? Now things are going to get a little more complicated, because I now have 2 to the negative 1 power. Well, 2 to the negative 1, it's a good one to memorize, is always a half. And I could write that as a half. I actually like to write it as a decimal though, too, especially when I'm graphing stuff. It just is better for my mind. And last but not least, I have 2 to the negative second power. So that's basically 1 over 2 squared, if I think about it, which is 1 over 4. And 1 over 4 is also a nice little quarter. Okay, so now I have created basically a set of coordinate pairs here, right? Let's start with this one, 0, 1. Okay, so I'm going to go over to x. Okay, and I'm going to zoom out. I'm going to start here. 0, I'm going to go up 1. Okay, now I'm going to do my second one. I'm going to go in the positive land. I have 1, and I'm going to go up 2. And then I'm going to go 2 over 2 and up 4. 1, 2, 3, 4, right? And if I kept going 3, what do you think actually, I'll just do it right now, all right? If I have 2 to the third power, I like that one, it's 8. So every time you go over 1, you're actually increasing, right? Exponentially, if you think about it, right? And then you're going to connect these. So this is not a line. It's starting to look like a ski slope almost, like a big jumping hill. I have some negative numbers here that I'm going to take care of. So now I have negative 1, and I'm going to go up half. I have negative 2, and I'm going to go up a quarter. So if I keep going, I could keep going for a very long time. And what happens is this is going to sit very nicely on the x-axis. It's never going to touch it. It's never going to cross it. This is actually known right now as the asymptote. I challenge someone to figure out where that name came from. Please, someone tell me. Then it'll tell me that someone's watching my videos. Okay, so I've done all this work, right? I have this like really cool growing, if you think about it. Like something is starting small and then it suddenly goes up. Ooh, really big and really big. And if I'm skiing up here, I might just fall right back down. So we classify this as a growth. And if I remember, it was 2 to the x, right, power. 2 is greater than 1, which means it's growth. If I think about the domain, which is really all my input. So I created, if I go back here, I created all these inputs, right? I could put any real number in here and probably end up with some y value. But the y values are not going to be just any number. It's very specific what the y is going to be. So the domain is all real numbers. And for now, we're just going to stick with all real numbers and a fancier way to actually describe that, but that's okay for now. Our range is going to be anything, any output, if you think about it, that's greater than 0. Because all of these are my y values up here, right? I don't have anything down here. So my output is not going to be down here at all. So y has to be greater than 0. My y-intercept, remember that was at 0, 1 I started. So let's put the coordinate in for now. And then my asymptote is really the x-axis, or when y equals 0. Okay. So now, my spidey sense is telling me I have a b, right? That's my b because it's raised to the x power. But it's a fraction. So b is smaller than 1, right? Which means it's decaying. Okay, so I'll have to remember that. So I'm going to set this up. I'm going to try to be neat, even though I'm tired and my phone is about to die. But I'm going to pick the same golden. I don't really know why I called it golden, but that's okay. There, okay. And let's go for it. So I have a quarter brought to the x power. So if I have 0, right, so I'm actually going to write all of these out because maybe you'll see the pattern, right? And you can get kind of faster at these as you practice, but this really takes a great deal of practice. Okay, anything to the 0 power is what? I think we said that was 1, right? Now I have something to the first power. I think that is itself. So I could write the fraction or I could write the decimal. It's always good to write both. And then I have 2 here. So I have a quarter that's now squared. So it means a quarter times a quarter, which is 1/16. Okay, so 1/16. It's also equal to like 6 cents. Okay. Now I'm going to go up here. I have a quarter to the -1 power, which actually means that it's just 4. So a fraction to the -1 power is the reciprocal. So it's kind of cool because it's just 4. Okay. Now I have a quarter to the -2nd power, which really means, if I think about it, it actually means, well, it means 16 if you think about it, because I'm taking 1 to the 4th and I'm taking the reciprocal and then squaring it, so it means 4 squared. Okay, so that means 16. So I have some drastic things going on here, and I have some kind of small things going on right here. Now let's go ahead and plot it. I'm gonna just go star my intercept and my 0 and 1. Okay, and I'm gonna start with that. So 0 and 1. A lot of these things start with 0 and 1. I'm gonna zoom out. Now I have 1, and I'm gonna go up a quarter. It's gonna be a little small right there. And then I'm gonna go to 2. I'm gonna go, 16th. It's getting really smart, and that's gonna be really hard to get any closer because I have such a dull pencil. And then let's go to the negative land. So a -1, and I'm gonna go up 4. 1, 2, 3, 4. I'm gonna go down -2. I'm gonna go up 16. What? Are you kidding me? Wow. 1, 2, 3, 4, 5, 6, 7. And I'm going to keep going, aren't I? So let's just pretend it's somewhere over here. Okay. In essence, what you're going to have is something like this. And remember, it's not going to touch. Okay, so it's decaying. So we're starting off pretty high, if you think about it. And then we're, okay? So we're like skiing down a hill, if you think about it that way. We're decaying down the mountain. Our domain is, again, all real numbers. So I can put anything into my x as my x. I just created them. The range, though, is anything. It's actually the same range as the previous one, right? Greater than 0, because again, it's only the top part of this graph. So anything is greater than 0. My y-intercept is the same as the previous one. Remember? Over here, at 1. Think about it right there. And my asymptote is also the same, because they're just both, if you think about it, they're a little bit opposite, aren't they? My asymptote is y equals 0. Okay, good luck. Bye.